All right, let's dive right into this explainer. Have you ever felt like typing out these incredibly long, tedious instructions to an AI is just, well, horribly inefficient? Or maybe you've wished you could communicate a really complex, multi-layered idea in a single glance. If so, you are definitely in the right place. Today, we're unpacking a fascinating, highly experimental cognitive architecture known as Emojiglyphics.
So think about this for a second. This is the central provocative question driving our entire exploration today. Human language is absolutely amazing, right? But it's linear. One word has to follow another. Our thoughts, though? Our thoughts are entirely multidimensional. We think in these massive webs of meaning, emotion, and logic. So what if we had an interface that actually mapped to how our brains naturally work, while also speaking directly to the structured mathematical logic of a machine?
To wrap our heads around this, we're going to move through 6 key areas. Beyond linear language, decoding emojiglyphics, symbols as computation, meaning through context, the human-AI interface, and finally, the future of intelligence. Let's get right to it.
Section 1. Beyond linear language.
Okay, this perfectly captures the concept of symbolic compression. We're looking at a standard, somewhat verbose English phrase, knowledge and cognition leading to insight and creation, stacked up against a highly dense emojiglyphic sequence. Now, the English phrase is fine, but it takes time to parse. But imagine a sequence instead: a brain, a stack of books, an arrow pointing to a light bulb, and then another arrow pointing to a construction crane. Instantly, your brain grasps the narrative, right? Learning leads to a sudden idea, which leads to building something new. But in this architecture, that's not just a cute string of pictures, it's a formal equation. We're literally compressing verbose text into a highly dense semantic token stream.
Moving on to Section 2, decoding emojiglyphics.
So what actually is this? The crucial thing to understand here is that this is not just about swapping out words for emojis. Not at all. It's about creating a formal, multi-dimensional system for expressing complex concepts. This framework fuses visual glyphs with strict computational structure. It essentially takes the universal accessibility of the emojis we use every day and binds them together using the rigorous logic of mathematics and programming syntax. To really get what's going on under the hood, you kind of have to look at it through 3 overlapping lenses at the exact same time. First, it is a language, complete with a real symbolic vocabulary and grammar. Second, it's a computational system, meaning those symbols are actually machine-interpretable representations. And third, it's a cognitive tool. It's a totally new framework for us to organize, compress, and explore our own ideas.
Section 3. Symbols as computation.
This is where it gets super interesting. By treating these glyphs as structured tokens, the syntax breaks down abstract ideas into a simple, followable procedure, a lot like a programming language. In this formal glyph calculus architecture, we aren't just making a collage of images, we're writing a functional sentence. You start with an input entity, say a brain for cognition, then you apply a transformation operator, like a directional arrow, and finally you point it to a target output. Input, transformation, output. It is modular logic that an AI can easily parse.
Now here's a real game changer. These symbols actually function as executable tokens that can steer an AI's operational state. Think about how much text you usually have to write just to tell an AI to iterate on a task. Well, this system proposes using something like the repeat symbol to instantly signal iteration, or an infinity loop to signal recursion. These are not just shorthand notes, they are operational state switches. They act exactly like code, aligning the machine's behavior to your intent in a fraction of a second.
Which brings us to Section 4, meaning through context.
So how does a system know what a symbol actually means? It all comes down to positional logic. A simple gear symbol becomes a highly specific analytical token when you place it next to, say, a microscope. If you just see a gear on its own, it can mean anything. But in this architecture, that microscope acts as a metaglyph mode marker. It explicitly tells the parser, whether that's you or the AI, hey, read the following symbols through a strict analytical scientific lens. So in that exact context, the gear definitively means a literal mechanical system or an empirical process.
But swap out that microscope for a theater mask, and the whole game changes. Instantly, the parser knows to read that exact same gear as a metaphorical construct instead of a literal machine. The mask metaglyph shifts the entire context into the realm of art or narrative. Now, that gear might represent the wheels of fate, or maybe the hidden machinations of a character's mind. The symbol itself didn't change at all, but its semantic environment did. Because of this insane flexibility, positional logic means a glyph's grammatical role can actually shift from a noun to a verb depending purely on where it sits. It interacts with its semantic field and relies on relational syntax. Ultimately, this means we can achieve incredibly high semantic density. We're talking about communicating a vast amount of meaning, tone, and logic in just a handful of characters.
Section 5. The Human-AI Interface.
This is the absolute magic of the whole concept. It proposes a unique dual bridge. Humans can engage with the emotional, intuitive, and mythic registers of the symbols, while the AI parses that exact same token stream as formal, operational logic. When we look at a string of emojiglyphics, we see visual associations and archetypes. We kind of feel the meaning. But the AI, it doesn't need to feel a thing. It just reads a structured, parsable grammar full of operational state switches. Both the human and the machine are getting exactly what they need out of a single, shared interface.
Finally, Section 6, the future of intelligence. Now, I want to be super clear about where this research actually stands today. While the grammar spec and the compiler prototype are very real, natively training this into AI model weights is still an aspirational goal. It's not a finished, off-the-shelf product yet. Right now, there is a working glossary of over 155 glyphs, a formal grammar specification at version 1.2, and an early prototype operating system called Glyphfield that uses large language models to parse prompts. But the grand vision, having an AI natively trained on this symbolic language from the ground up, that is the exciting frontier this project is pushing toward.
Look, like any experimental cognitive architecture, we have to weigh the massive benefits against some very real challenges. The potential for visual reasoning and cross-modal collaboration is frankly incredible. But when you compress information this densely, you absolutely risk ambiguity. How do we standardize this globally? How steep is the learning curve? Making sure a machine stays grounded and doesn't completely misinterpret the symbolic intent is a huge hurdle that researchers are actively tackling right now.
Ultimately, think of Emojiglyphics as a symbolic crosswalk. It's not here to replace natural language. Instead, it offers a totally new multidimensional canvas where human imagination and machine logic can actually overlap. We can integrate the symbol for medicine, the atom for science, and the yin-yang for philosophy into one cohesive computable string. It's an attempt to create a shared interface where empirical logic, computer science, and our deepest human knowledge can all be processed together. I'm going to leave you with this final, provocative question to chew on as we keep pushing the boundaries of technology. If language is one interface for intelligence, what other interfaces have we yet to invent? Emojiglyphics is just one experimental glimpse into that future. It absolutely challenges us to think bigger about how we connect our intuitive human minds with the vast power of AI. Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll catch you next time.